So good morning, everybody. I think we can start with our webinar. Welcome all. So today we will present our advanced vehicle development with the Kistler testing solution. During the webinar, we will present Kistler, and then we will pass through the DTI technology, that is our technology for the vehicle dynamics, durability, and tire testing. Then we will have a tour around our demo car, and then we will point out some new product and solution. And at the end, we can have an open discussion with our application specialist. So Kistler, it's a worldwide company with more than 60 locations worldwide and over 2,200 employees. We have more than 10,000 active customers, and we work also with the university and R&D partner in order to achieve the best solution for every application. Our concept is to reach customer through the sales center in order to advise customer and to administer the sales process and offer service in multiple countries. We have also tech center where we provide services like calibration, repairs, adaptation, customization to our product, and we train also our customer. And then in the back line, we have our competence center, the production center, and support center. That is the core of Kistler. Kistler, it's a Swiss company. The headquarters is in Winterthur, near Zurich. And we have many other locations in Germany and also in US, in China, and in Japan. Today, we are divided in three, let me say, business units. They are called automotive research and test, industrial process control, and sensor technology. In the automotive research and test, we are focusing engine research and development in engine, marine, and stationary. And then, of course, vehicle dynamics, durability, tire testing, and vehicle safety. We have also the, as I mentioned, division that is focused in industrial process control, and here we have different applications in order to support the production, like for plastic, for the test automation, fastening technology, production monitoring, and so on. And then at the end, the last division, it's related to testing in different other markets, like, for example, in biomechanics, in road and traffic, in aerospace, and overall test and measurement where our sensor can be applicable. So now I will give the, I will pass to Martin the microphone, so Martin can introduce our DTI technology.
Okay, so good morning, everybody. Also welcome from my side. I will have the second part of this webinar talking about Kistler's DTI technology. My name is Martin Degen. I'm the business driver for vehicle dynamics, and I'm located in Wetzlar, which is quite in the middle of Germany, and Wetzlar is the city of optics, actually. So we have here a lot of companies like Zeiss or Leica, which are a good supply base for our optical sensors. Maybe some of you know our optical speed sensors like the L motion, S motion. So this is coming from here. And so I will take over the next part, and also you can see here our application team, Igor and Yves Behr. They will give you the tour around our demo car later. So here again, the slide with our team, Igor and Yves, which will show the demo car later. And now we will start here with our topic regarding DTI. Maybe to get a good introduction into the topic, just a few slides about vehicle dynamics. So what is vehicle dynamics about? We can see here vehicle dynamics is about all the forces and moments around the car in all three axes. And what we want to measure are forces, moments, angles, and rolling resistance, for example, and other stuff. This is mostly done in some kind of standardized maneuvers. I guess most of you know those things. I will come to this later in the fourth part with some new development on our side here. And to perform all those measurements, you need quite a lot of sensors. This car, I think you have seen it in the presentation of Andrea already. I added some sensors which are necessary to measure all the stuff you need for vehicle dynamics and durability, like acceleration, braking pressure, dynamic camber angle at the wheels, pitch and roll angle, slip angle, and so on, steering forces and moments with the steering wheel. We have here temperature sensors, acceleration sensors, CAN interface for the vehicle CAN bus, also strain gauges, wire potties, and of course here our optical sensors to measure the speed at each wheel and also the angles, slip angle, and dynamic camber angle. And this big thing here is the wheel vector sensor, which can measure all the movements and angles around the wheel. So this is something you probably need to install in your setup. And I'm going to show you right now the solutions with Kistler DTI systems. So the basic idea behind the DTI, which means digital transducer interface, it's coming from our crash department. This was the idea: how can we integrate a lot of different sensors into a data acquisition and reduce all this cabling and really do it in a efficient way to save time and money for the installation and also for the measurement later. So what you can see here, this is the backbone of our concept, to have a bus system, a digital bus system where you can connect all the different sensors you need to have. And this is what we try to provide. So actually we do everything what you need to do with the sensors, like configuration, synchronization, and setup, everything with one cable. And we want to get rid of the variety of different sensor cables and different data acquisition modules with different mating connector slots, what you need to have available to connect all your stuff. So this is the basic idea. This is shown again here a little bit. So this slide shows the four main functionalities. Of course, data transmission, the synchronization of all sensors with a timely, precise timestamp for all the sensor signals. The configuration. So if you use the standard versions of our sensors, you probably have to connect to them with USB or Ethernet, do the configuration, and then in a second step connect it to the data acquisition. This is not necessary with DTI. You can do it directly with this one bus cable, and also the power supply is provided with this one bus cable. The technology is based on RS485 standard with a 16-bit message, and there's a lot of detail behind it. If you are interested in that, we can give you more details in other tutorials. I will go over this a little bit quickly because you are maybe more interested to learn about the major benefits of this technology. And to show this a little bit more visually, I have here a comparison as a principal example. So if you have a car, you want to prepare it with different sensors. You can see here different types of sensors: acceleration, strain gauges, pressure sensors, temperature, also the wheel sensors, and also as motion at the back, for example. So those are all available as standard versions where you can connect it to a standard data acquisition system, which will probably work with CAN or analog inputs. And then you have to do the connections with all the different cables to the data acquisition. And most probably you also would need several other cables to provide the power supply to the sensors, depending on the sensor type, of course. With the DTI system, this is a little bit different. So actually you would have only one bus cable, which is going from the data acquisition to anywhere in the car, where we could have hubs to collect different sensors to this hub and go with one bus cable to the data acquisition system. Or also possible would be a special cable where you have different sensors already connected. But maybe this is a very special solution, so I always would prefer to have this flexible hub version. And yeah, here a standard slide which summarizes a little bit the benefits. So you have one cable for data synchronization, configuration, and power supply, and you could have a decentralized data acquisition option because you could really place all those hubs exactly where you want to have it in the engine compartment, in the trunk, or somewhere at the chassis, and go from this point with one cable to the logger. So this right picture here is showing the logger, and what you see here, the connectors, the Ethernet connector, this is going to your laptop, and you have one connector for the power, and then you have 8 identical connectors for the DTI buses. And here it's really, it doesn't matter where you plug in your stuff, so the system will automatically detect which sensors are connected where, and in our software surface you can directly see, if you hover the mouse over this port, which sensors are connected, are they active, are they live, do they have any issue, is the calibration outdated or whatever. So this is a very good thing to have everything at a glance. Here's some more details. I would not go too deep into this, but if you want to learn about the principle behind the DTI, how it's done, the data transmission on the bus with different sample rates, and I can explain this in another tutorial or provide this information later. Maybe the important thing is that this logger is really able to provide up to 240 watts to all your sensors, and so far with our setups we didn't discover any issue here regarding power supply. Yeah, so this is again the summary of the functionality. So we have the TETS functionality, we have the automatic sensor identification, and you could also type in the exact position of the sensor, so you have already this information. If you open up your measurement file later, you can exactly see where this sensor was placed. As I mentioned before, the data transmission, synchronization, configuration, power supply, this is all done with one cable, and you will receive really physical values from your sensor. So you do not have to recalculate millivolts per volts in your data acquisition system. If you plug in a sensor with our DTI system, you will get newtons, you will get kilometers per hour or whatever the sensor is delivering in the right standard, international standard unit. Here you can see the architecture behind it. That means the DTI system is not closed and not restricted only to the Kistler stuff. So we are open to integrate any third-party components. And of course, for us, the best way is if the conversion of the sensor signal to the DTI world is done inside the sensor. This is most probably the most cost-efficient way, and also from the space you need to build up. And then you go with a simple one-to-one DTI cable to your logger or to a hub. This converter can be somewhere in the cable, either in a fixed way or also with connectors, mating connectors to your standard sensors, what you already have, in order not to lose the capability to use them with another standard data acquisition system. So this is all possible. And basically, we are doing the conversion of the sensor signals with a small electronic, which does the signal conditioning, the filtering, and also you can do the offset calibration and linearization in this small electronic unit. There's a signal conditioning, a microcontroller stage which does all the calculations, and then of course the output stage which gives this out to the DTI bus, and the size is quite small. Currently we are working on a new generation to reduce the size again, and also to be more flexible and provide other functionalities as well. I will come to this later. Here's an example of a vehicle setup for dynamics and durability, where we use up to 3 loggers, because you probably have a lot of sensors to be connected, and this is just one example. So we have 2 loggers for the dynamic stuff, for wheel force transducers, for S-motions and vehicle CAN. Then we have the wheel vector sensors at each wheel, and also to measure the dynamic camber angle, we have our DCA system 4 times at the car. We have a measurement steering wheel, several acceleration sensors, pedal force transducers, and so on. And also for the durability part, we have an additional logger where we connect the strain gauges and also additional acceleration sensors and travel sensors for the displacement of the suspension, for example, and other temperature sensors. What you need here is a 3-logger system, 1 sync switch. This sync switch is needed to have really all single loggers synchronized to the system. And we have a small amount of hubs, which can be placed anywhere in the car, and some converters. We checked, of course, how this could be done with other data acquisition systems. And here we choose, of course, our internal stuff. This is our TDAC, but you could also compare it with other competitor products. I mean, they are all okay. You can do everything you need also with other data acquisition system, but already here you can see that this will build up quite a bit and produce quite big setup for the data acquisition system. And what not to forget, if you use this standard data acquisition system, which has no DTI and no bus system, but only analog inputs or CAN or specialized connectors, you would also need for the S-motion and measurement steering wheel and the RB4s and so on, the standard version sensors, which need additional controller boxes. So this stuff would also stack up at your data acquisition system. And so the space needed is not negligible. So here's another example, which is even more challenging. So this is a thing we worked just recently on. This is a car setup with 350 sensor channels. Sensor channel here means 350 sensors. Each sensor itself can provide much more signals themselves. So for example, the S-Motion delivers for itself around 30 signals or so. So this is just the amount of sensors we want to connect. And what you can see here, we can do this with 2 loggers. We have a lot of sensors here, like also measurement steering wheel, RV force, displacement sensors, and this part here, it really a lot of temperature sensors. And we have special modules which will be suitable for the temperature measurement, and then we can also provide more channels, and those modules can be placed anywhere in the car, and you go with one DTI bus cable to the logger. And if you compare this with a standard data acquisition system, in this case again our internal product, this would look like this, and again you would have additionally ECU houses to be added here. So here just a few slides how those sensors can be connected to the different bus ports here. I will not go into the details about the port and slot stuff and how many you can connect. So this is a detail I can explain in a different tutorial, but actually you see you can connect 4 wheel force transducers to the logger. You can connect the S-Motion sensors and the RV force and the DCA systems. Everything is possible to connect here. The third logger with the strain gauges and the other stuff. Here we have the possibility to do the conversion to DTI in different way. That could be inside the cable with a small tube housing, which is IP67 suitable, or with a small box with more channels. So this is also a flexible solution. And here, by permission of Kartek, I can present you the real car, how that looked with everything installed. We did this last year and used here the first time our new versions of the real vector sensors and the DCA system as DTI versions. And here the good thing is you really just go with the DTI bus cable directly from the sensor to the logger. There's no other electronic unit needed in between. And this means the installation is quite easy and quick. And here you can see how the data acquisition system was placed in this Audi R8 car. There's not so much space behind the seats, and it just fit right good here behind the seat. And now imagine you have those big boxes of another data acquisition system and additional ECU housings and how you have to connect those many different cables, and if you are trying to figure out if everything is connected right. So here you just plug in anywhere in the logger and it's working. You do not have to care which sensor is connected where. You can also see here at the back of this picture, we can integrate platform from Oxford, and in this case, and here a little bit the mounting of the measurement steering wheel. Of course, we also have solutions which do not build up this much. I can show you this later also, or Yves and Igor will show that. And here my summary of this DTI technology. So our data acquisition system is really the focus to be small sized and specialized for the vehicle dynamic and durability applications. We do not want to compete with all the other standard suppliers for data acquisition systems. This is not really our goal. Our goal is to be able to provide complete package solutions. So if you want to have a complete setup for a car, we are not only able to deliver the sensors, we can also do the data acquisition and provide everything out of one hand, and you can be sure that everything really fits together. So the digital control, configuration, synchronization, power supply, and measurement, everything over one cable. And this is, I think, the really most important point, to save setup time and effort, reduce the cabling and also the weight and the space, of course, and also saving troubleshooting time. So if you are on the proving ground, which is quite expensive, you most probably would be lucky to not use your time to troubleshoot your setup and work around with hundreds of cables and looking for bugs and issues. So actually this setup, which was a quite big setup, this took us all in all from going to the place. We had to move to another garage, unpacking, checking everything, installation, setup, and in order to be able to go to the racetrack, it took us 2.5 days. And I think this is a quite short time. And it was working. So here just as a final look to our product portfolio. I don't want to go to all the sensors. It's just an overview to show that most of the important sensors which are needed are already available as DTI versions. Of course, they are still available as the standard types, and basically we will provide the sensors with DTI outputs and CAN outputs. So you will not be forced to use our DTI system as a data acquisition system, but it's an option which would provide, I think, a lot of benefits. Our software is the KI Center. So all the configuration and measurement and also checking of the measurement, this will be done with KI Center. Here's a small example for a brake test. So this is just to give you an impression how this is looking. You can create different kinds of displays like digital or graphs or tachometers. You can go back to the measurement, zoom in, check if everything is okay. This is in the new data center. It's also in the standard KI Center version, which will be free of charge, delivered with a logger. So you have the possibility to make a plausibility check of your measurement before you go on with your next measurement. In addition, we have some more software products to do the complete management of your data, also worldwide, with a lot of big files and a lot of data. So this can all be handled with Madam. Also with different teams on different places on the world. You can work with the same sensor data and measurement data. And our new analysis software JBeam is something we are using to analyze our stuff. So, and maybe now I would try to switch to another view to give you an impression. So this is how JBeam is looking. For example, what you can see here is it's a large menu with possible mathematical functions and filters and things you can do, conversions. You can do your own setup of your layout, produce statistical data. You can put your track data on a Google map, for example, which is controlled by velocity data. So this is the colored data here. You could also use this as a opportunity to move around the track and watch your data here on the graph. Do this with a cursor and track the cursor and see what your measurement was at this place. Maybe here's another example. So here is a smaller course. And what you can see here, so the car is moving around that course. You can follow the measurement data, and here are some other values displayed for the wheel forces at each wheel. So here, this is a quite flexible thing which you can create, and you can also use this and export a report as PDF and create your report documents out of JBeam. So that means another example of a circular drive. So you can see the data, just an example. But what I want to show here is that we provide the complete measurement chain from the measurement hardware and setup and software to the final analysis software. The data exchange is done by, or it's possible by different formats. You can use the RPC3 format, or in the latest version, we already have included also the ADF converter. ADF is the native file format of KI Center, and it can directly be dragged and dropped into the JBeam, and you have all the signals there and can place it in different displays. So it's really drag and drop and quite easy to handle. Good, so that was all from my side. I think if you have questions, I'm happy to answer that later. For the next part, I would give over to Igor Fast and Yves Behr, and they are now in our shop floor and showing you this demo car where we have some sensors installed. And now, Igor, it's your time.
Okay, thank you. Good morning from my side. My name is Igor Fast. I'm an application specialist, and I'm responsible for the dynamics and also durability application, but most focused on dynamics products. And my colleague, Yves Behr.
So hello everyone, also from my side. My name is Yves Behr. I'm also responsible for dynamics and also for durability as well. And I will give you today the tour around the GTE, our demonstration car. It's a hybrid car and it's from VW. And yes, so now we need the video from the camera, Valentina.
From the moving camera?
Yeah, from the moving camera. So now some information about the sensor. So as I mentioned before, we have here some pressure sensors in the engine area, also some accelerometers. For example, here at the suspension turret, we also have accelerometers here placed at the engine area. And all those sensors were collected in one hub. So as you can see, you can compare it to my hand, it's very small. So this is a big advantage of our system. So we collect all the sensors here. So this is our decentral system, and we go with just one cable into your data acquisition, in our data acquisition system. Here, for example, the hub again. So we have here 8 ports where you can connect 8 sensors. We also have the possibility to modify, to convert all analog signals to a digital signal with our DMOD. So you can see here, for example, the black box. This is actually an old version of our digital modifier, and here you can see our new digital modifier, so DMOD called. So it's just fingerstick, for example, so it doesn't take much space. So we also have a kind of collecting box for strain gauges. It's our strain gauge converter box, so you can use it for durability applications, for example. So you can collect a lot of channels here and also go with just one cable into your data acquisition. If we go now in the front of our car, you can see the light underneath. or in front of our bumper, there is an S-motion placed straight directly here. And this is our correlate sensor, where we can measure different signals like speed, that yaw rate, angle, slip angle, and so on. Also acceleration, yeah, and so on. So then you can see here on the side, we have here mounted a wheel force transducer. It's a S625 carbon wheel, where you can measure in all 6 degrees of freedom. So we can measure here forces in Fx, Fy, Fz, and also the moments in all directions, Mx, My, Mz. So now we go to our measuring steering wheel, which you can see here. So it's directly mounted behind the original steering wheel, so you still can use your original steering wheel for your measurements. So also the airbag function is still available as before, and also the buttons here still work as before. You also have the possibility to mount it in front of that, but this is not done here. So if we go now to our data acquisition in the rear.
Of the DCA system.
Oh, sorry, I forgot the DCA system here at the rear. With here our DCA system, these are the 2 HF sensors, so height sensors combined to one sensor, and this sensor measures the camber from the wheel to the road, camber angle. So if we go now to our trunk, there is all our data acquisition system placed. As Martin already mentioned, here you can see our logger. So we have here 2 loggers in our GTE, and they were combined in our sync switch system. You also can see the electronics of our S-motion, our MSW, and also the key road performance, which is for our wheel force transducers. We also have CAN converters, so you have the possibility to connect a CAN signal sensor directly to our logger system. All this is powered by a separate battery which is placed underneath this here, but you also can use additional power supply, maybe from your car as well, or it's in your hand. So actually that's it from my side. Maybe now we will go over to Igor, and he will show you a little bit more about KI Center, how we measure.
Now I will show you some functionalities of KI Center. And for this reason, I prepared a configuration, as you can see here. And for first, I have to connect my notebook via Ethernet cable with the DTI loggers. We are here in the device center. Now it's running and searching for connected devices. You can see here 2 devices are connected, 2 loggers. And for example, here are the main information. Here, 1 logger with the usage, some main informations, which sensors are connected. You can see here some K-beams, some pressure sensors, and so on, strain gauges. You can also see where on which port. If you go over this sensor, you see on the right here there is a blue light. It's shining. Where is the sensor connected, for example? It's the same as a second logger, and so on. Okay, now we will go to the test center. Inside the test center, you have the equipment. This equipment shows which sensors are connected under the logger, and you have here the possibility to set the downsampling or some and to see which sensors are connected. In our case, we have 19 sensors here, 2 converters, S-motion, and so on. For example, this is the point what Martin mentioned before. If you have a DTI device, for example, our S-motion is a DTI device, also the MSW, you have the possibility to do the configuration over one cable. You don't need to connect first your electronic to configure the sensor and to connect after this with the data acquisition system. You can handle it here completely over the KI center. You click on the S-motion, and then you have here the main information. You have settings here, angle, offset. You can do the settings here, the point of interest calculation, and so on and so on. And also you see here the DTI channels that are given by S-motion, more than 30 channels. And you can do also here the calibration of the device over this functionality. For example, sensor calibration. There's the button on top here. If you push the sensor calibration, in this case, the system asking, okay, what do you want to calibrate? Do you want to calibrate the angle or the distance? And for example, the standard calibration is the angle. You do the straight driving for 100 or 200 meters, and then some misalignments are calculating. Okay. This is the big advantage of DTI device. The same also with MSW. You can do also the configuration. Yeah. Then we have some K-beams and strain gauges and so on and so on. You can do also the configuration of the K-beam here inside. The direction of the K-beam, you can switch the direction. And most interesting point is you can do the measurement with your KI center, with the test center. In this case, I prepared one test. Also here, you can set some important settings, sampling rate, and so on. Your start trigger, for example, if you do the brake testing measurement, your start trigger could be, for example, the pedal force sensor, or the speed, for example, motion signal, and then you choose the velocity. And then you said, okay, if you reach the velocity more than 100 kph, then please start the measurement and end the measurement under 2 kph, for example. Yeah. Okay. And so I set the trigger as a button here. For us, it's easier. Then you need display. For a test, you need a display. I prepared one display, on demo display. I did it before in my office. By drinking a coffee, I prepared this display, for example. I will show you after this how to do this display from scratch. And now, if you set all these settings, for example, also the save directory and so on, with the button F6, it is a quick view button. You can see the live data coming by each sensor. It's just a short overview. Are all the sensors here? If I have values, for example, now I have here more than 100 different values, and this is just for the quick view. If I'm sure, okay, all the sensors are here, I'm ready for measurement, I will press F5 button. F5 is meaning start the measurement. And now the system
is waiting for the start trigger. And if I push my button, the measurement is already running right now. And my colleague Yves will shaking a little bit the car, just a little bit. And on the left screen, on the left chart, you see the roll angle coming by S motion and the camber angle coming by DCA system. You see a wonderful, nice sine sweep coming by FZ forces from VFW, VFTs from our force wheels. And for example, here that our MSW, okay, you cannot see the velocity, the car is not moving. And also you can here see, for example, the LED. You can set the LED for your measurement. For example, if some temperature values are reached, please switch from green to red. And yeah, now the measurement is finished. You stop the measurement again with a button by pushing the button. Okay, and now you can see in the end display, you can see your values. You can zoom in, you can zoom out. You have the same functionalities like in a data center. For example, here, I want to zoom in here to check my forces here, and in this case, you can swap the bar and show the maximum or delta values, so on. Zoom out. So if you want to save this this data, it will be saved automatically, or you can quite it. And short overview of a data center. Now in our data center, inside the working directory, I have two different measuring files. One file is measured right now. This is our webinar file. And if I want to see this file, I have to double click it. And for example, I have here the signals on the left. I can do it like this. I can drag and drop the force inside here, or I can show for the signal with the right button and check the roll angle, for example. Yeah. And also here, zoom in, zoom out. This is the functionality of data center. Is just a short, quick visualization and plausibilization of the data. It's not able to do some calculations or things like this. These things you can do with JBeam, for example. And with data center, you have also the possibility to convert our data files, our ADF format, into most common formats. For example, you see here the converter on the left here in the tree. You can convert to ASCII, to RPC, to MDF, to TDM. And if you want to convert this data file, for example, you have to choose the current converter, for example, the RPC3 format, and then convert selected file. The conversion is already done. This is a short overview of this possibility. Now I will show you just short overview how to create a new configuration, for example. Let me take a place inside the car for this reason. It's a little bit more comfortable. That's staying in front of the car. In this case, I need a new configuration. I push on the left button. In this case, I have to reconnect my loggers. Okay, the system is searching for connected loggers. Okay, 2 loggers were found. I will go to test center, and you see inside the test center nothing. You see the equipment, it's green here. I have a connection and I have these sensors here. For example, okay, I want to have some signals from K-beam or from some other sensors. I select the sensor, I select the generate signals, and then I push generate signal. The same also for another sensor. MSW, generate signal. Fine. Okay, now I need a display. I will go to add display, and my display should be a chart, for example, and I can split it. I have a small chart, and I need a digital value, for example, and here's also digital. And I can drag and drop, for example, my steady state circular driving. I need a ACCY signal, and I need, for example, steering angle. So, and I need a new test. You can give the name of the test, set some things, and I will choose this display. Run display, start display could be different displays, and end display could be also another display. And then you are ready for measurement. You will press F5. Okay, I see some values are changing. Okay. You see how quick you are ready for measurement, and you can do it. The preparation of the configuration you can do in your office by drinking an espresso or something like this, and do it in comfortable way. And after this, you save the configuration, you connect the loggers, and then do the measurement. This is from my side to KI Center. If you have some further question, please ask us in the last part, in the question part. And thank you from my side for be patient for my explanation. Thank you, and I will stop my screen and stop my video.
So next part, I hope you can hear me. Good. So this is a little bit about the upcoming highlights. First thing here. This is our new data logger extension called Keystore. This is a standalone version of the logger. So if you remember the overview setups of the systems where we have a laptop, not everybody likes to have a laptop in the car and measure with a laptop. This was the reason why we also designed now this on-top box as a standalone logger. This can be connected to either one logger or to the sync switch with 3 loggers, and is autonomously storing all the measurement data. This can be transferred later via USB, for example. And you are able to control the device with your mobile phone or iPad or whatever. So the user interface is a web-based software, and it should run on almost all mobile systems, Android, and so should be no problem. So that is upcoming and is planned to be launched in October. The first prototypes are already there and working. If you remember the stack of our data acquisition system in this small area of the test car, same thing could be used on a motorbike, for example. So where you have really limited space and you want to have your autonomous data acquisition system placed somewhere. So this is a quite good extension, I think, soon available. Next thing, I showed this slide with the ISO maneuvers, what most of your test engineers maybe have to follow. And now we have a cooperation with the company Magix, and they did a software called Moses. Maybe some of you know it already. It was developed together with Daimler. There is a lot of experience behind it since 15 years. And they have a large maneuver catalog. So if you go to the homepage, you can see that. Maybe it's opening. Hope so. Okay, maneuvers. So and here you can see all the maneuvers which are already implemented in this software. And the Moses software is the guiding through the measurement. So it really tells the driver or the test engineer what to do next, and it also will do a plausibilization after the test. So the test engineer can check if everything was okay and if he can go on to the next test, or if something has to be repeated, so that you will not be surprised if you go back to your office and discover that some of the data is maybe not as you would like to have it. So we have a new API created between Kistler Center and this Moses software. That means, as you can see in the picture, they already worked together with Kistler some years ago, but those are the standard versions with CAN and so on. So with this software, you are able to measure via CAN or FlexRay or whatever, but also with the Kistler DTI world. So this is the new thing behind that.